suppose we had these two functions, both of them quadratic functions. And if I wanted to find f composed with g of x, that's f evaluated at g of x, which means wherever there's an x here, I'm going to replace it with that entire expression. Wherever there was an x here in the function f, I replaced it with the entire expression for the function g. Now, to simplify that expression, I'm squaring a binomial. To do that, remember, we'd actually have to use FOIL, which could get a little messy. It's going to produce a multi-termed, probably three-termed polynomial expression. But if the only thing I wanted to know was what would be the function value of f composed with g at -1. Well, rather than going through the work of creating that composition function, what I can simply do is, first of all, evaluate the function g at -1, take that answer and evaluate the function f at that value. That's probably going to be less work than going through the effort of composing the function. So the square of -1 is 1. 3 times 1 is 3. So here's what, put it down below, here's what we're actually doing. I put -1 in place of x in the function g. So the square of -1 is 1. 1 times 3 is 3. So I'm now going to find f at -2. So that gives me 2 times the square of -2. The square of -2 is 4, and 2 times 4 is 8. So the value of the composition function at -1 is equal to 8. And I found it not by going through the effort of forming the composition, but by simply first finding the value of g at -1 and taking that value and plugging it in for x in the function f and evaluating that. And so I was able to accomplish my goal of finding f composed with g at -1 without having to actually form the composition function. Let's try that again. Let's suppose we wanted to find f composed with g at 3. So we would first find the value of the function g at 3, take that answer, plug it in for x in the function f. So 3 squared is 9, and 3 times 9 is 27. Ooh, this looks like it's getting to be a big answer. Maybe I should have picked some smaller numbers, huh? If we're going to evaluate, in fact, let's pick a smaller number. I'm going to chicken out and pick a smaller number. Let's go with 2, since I didn't bring my handy-dandy calculator. So put in 2 for x. 2 squared is 4. 3 times 4 is 12. 1 minus 12 is -11. So the function g evaluated at 2 gives us -11. And now we'll evaluate the function f at -11. The square of -11 is 121. 121 times 2 would give us 242. So the value of f composed with g at 2 is equal to 242. And how did I find it? I found it by first finding g at 2 and then taking that answer and evaluating f at that answer. Rather than going through the effort of finding the composition function, I can find values that way. Now, if I'm going to need to do a lot of things with that composition function, then it might be worth my while to actually find the expression for it. But if I just need to get a couple of values, this may be actually a quicker and less involved way to do it.